Jai Hind, welcome to the course Network Analysis and Synthesis, and today I am going to discuss about the gate function. Gate function is being used to carry out the waveform synthesis. In the previous lecture video, we have discussed singularity functions, and using the singularity functions, we have carried out the waveform synthesis. So this is another approach to carry out the waveform synthesis. The first we'll discuss what is gate function and how gate function is being used to carry out the waveform synthesis. So it is a function comprising two unit steps functions. So this is a graphical representation of gate function. So we can see that if we want to construct this gate function, then we have to take this unit step and we can take another unit step starting from this. Ut minus t. So we earlier studied the shifting operation on unit step. So if you take these two steps functions, we can create gate function. So basically gate function is a combination of unit step functions. So this is denoted by G0t. And G0t means this 0 is starting point. This is the starting point of the gate. Starting point of gate signal. And this t is nothing but duration of gate. Duration of gate function, or you can say okay. So gate is a function which starts at t is equal to 0 and lasts for the time capital T. So if we want to write the mathematical expression of this gate function, we can write in this way. So G0 to G0t is gate function. So ut minus 0. So if you want to write this ut is ut and this is ut minus t. If we deduct ut from ut minus t from ut, we get this. So this is the graphical representation of gate function. So if you suppose I take this another, this is another gate. Suppose this is the T0 and this is T0 plus T. And the height is always 1. Okay. So if you want to denote this rectangular pulse, so it is denoted by T0 and in the bracket it is T. So starting point is T0 and duration is capital T. So we can write the mathematical expression of this gate function. So here we can write G0 G T0 T is equal to ut minus T0 minus this t minus t. So it is of duration t. So T0 minus T0 minus t. So it is, so T0 cancel out, it is T minus t. So we take this and this. So we deduct this one. So we can get the gate function. So what is gate function? Gate function is a rectangular pulse of unit height. So height is 1 and it is a rectangular pulse. It starts at t is equal to t0 and lasts for the duration of t. So what are the salient features of gate function? So it represents a rectangular pulse of unit height which starts at t is equal to 0 and lasts for time t. So if the gate function is this, so it starts at t is equal to 0 and the last for capital T. So any function multiplied by gate function would have non-zero value only in the duration of gate. And what is the duration of gate? Duration of gate is t less than 0 and t greater than 0 and it is less than capital T. Or function will have 0 value outside the duration of the gate. So the value of the function within the gate would be unaffected. And what is the utility? What is the utility of gate function? Because it erases all the unwanted portion of a continuous function without carrying out graphical composition just by shifting, addition or subtraction. So if you remember, by using the singularity functions, unit step, ramp or shifted unit step, what we do, we just add and subtract to get the required waveform. In this case, if we multiply the function with gate function, we need not to carry out the graphical composition. So this will understand with the help of some examples to carry out the waveform synthesis using the gate functions. So these are the salient features. It is a rectangular pulse of unit height, and any function multiplied by gate function will erase all the unwanted portion of the graph. So just take one example. Suppose take this wave shape. Suppose this is the wave shape and we have carried out the waveform synthesis of this function using the singularity functions. So now we just use this function by gate function. So here we can write the expression of this function. So ft is e by t into t. Okay, so this is the equation of the line e by t into t. If we multiply with the gate function, so ft is equal to e by t into t. What is the duration of gate? So gate will start at t is equal to 0 and last for capital T. So this is G0 and this is T. Okay. So this can be written as e by t t u t minus 0 minus u t minus t. Okay, we can write now e by t t ut minus e by t t u t minus t. Okay, now we can further simplify it. E by t tut minus e by t. So this t can be written as t minus t plus t. So this t can be written like this, u t t minus t. Okay. So ft is equal to e by t okay, now minus e by t minus t u t minus t, okay, minus e by t into this t u t minus t. We can write. So first I have taken this one and this, and the next term is e by t into t u t minus t. So if we take the Laplace transform of this, so this t is cancelled out. So ft is equal to e by t tut minus e by t t minus t u t minus t minus e u t minus t. Okay, so we can see that we have written the function in terms of unit step function. Now take the Laplace transform on the both sides. Take the Laplace transform on both sides. So ft is, it is fs, and what is the Laplace transform of tut? So it is e by t s square, because we know that rt is equal to tut. So this is the relationship between unit step and ramp function. Okay, so we know that the Laplace transform of ramp is 1 by s square, so it is 1 now this, so it is just shifted e by shifted ramp e by t s square e to the power minus ts, and the third component is, it is shifted unit step, so it is by e by s e to the power minus ts. Okay, so this is the Laplace transform of given function ft. So this is the way we can carry out the waveform synthesis using the gate function. We can verify this result with the help of your graphical composition. So we can alternate method we have studied earlier. I am just reminding you here. So this, suppose this is your one cycle sawtooth. So this ft, so this ft can be, if you take so this can be break into like this. Suppose take a ramp of this, then take a ramp, this ramp, f1t, this is your t and this is your e, and take So this wave shape can be decomposed into three functions, some signals. So here it is a ramp with positive slope. This is shifted ramp with negative slope, and this is a shifted unit step. So we can write. So what is this? What is this Ft? So F1t is equal to E by T, and it is T. So it is RT. Okay. This is your F2t. So F2t is equal to, this is your minus, so minus E by T R T minus T, and this F3 is minus E U T minus T. Okay. So Ft can be written as E by T RT minus E by T R T minus T minus E U T minus T. Okay. So this is a ramp. This is the shifted ramp, and this one is the shifted unit step. The straight way we can carry out the Laplace transform here. So this taking the Laplace transform. On both sides. So this is Fs E by T S square minus E by T S square e to the power minus Ts. So it is a shifted ramp, shifted by time capital T, and this is the shifted, so it is E by S e to the power minus Ts. Okay. So this is the another approach. So this is we have carried out the waveform synthesis here by using the graphical composition. What I have done, I have taken the shifted ramp and shifted unit step, and we have constructed this, synthesized this wave shape, and then write the equations and take the Laplace transform. So what is gate function? Gate function is another way to synthesize a waveform without carrying out any graphical composition. So this is the difference between using the singularity function or using the gate function. We can take another example. So we can look at this. Take this. So this is, suppose this is your minus E, this is 0, this is E, and this is your T. Okay, and this is T by 2, and this is your Ft. So you are required to synthesize this waves for using the gate function. So what you have to do, you have to first write the equations. So you can write the Ft. So Ft is, what is the slope of line? So minus 2E upon T. This is the slope of the line, and it is plus E. Plus plus just right here. So ft is equal to minus 2e upon t plus e, okay, into t. So this is the equation of the line and multiplied with gate function. So what will the gate function? Gate function will start from the 0. So this is the gate function. You have to multiply this gate function. This is your t. This is your rectangular pulse, and this is the height. So you have to carry out. You have to consider this gate function. So g0 t. So we can further write. So ft is equal to minus 2e upon t plus e into t u t minus 0 minus u t minus t. Okay, now break this one. So basically it is minus, sorry, this t here you cannot write t, this is the t. Why we minus mx plus c, minus mx plus c. Okay, so c is, this is e, and this m is minus 2e upon t, and this is t. Okay, sorry. So we can write minus 2e upon t into t u t minus 0. Okay, again then this minus minus plus, so this is plus 2e upon t into t u t minus t. Okay, so I have written this one. Now come to this plus eut this term, then plus and minus, so it is minus, so minus u t minus t. So this is the expansion of the function. So ft is equal to, this ft can be written as minus 2e upon t into t ut. Again this can be written like this. Take this outside. T can be written as t plus t minus t, t minus t plus t, because just I am converting this in terms of the shifted ramp. So t minus t plus t u t minus t plus e u t minus u t minus t. Okay, so we can write here, again write here this, so minus 2e minus, so ft is equal to minus 2e upon t, this one, into tut. Okay, then take this one plus 2e by t, t minus t ut minus t, then plus 2e by t into t, this term, this t ut minus t. Okay, now then the remaining minus e t minus t. Okay. So we can write the Laplace transform of this. So Laplace transform of this is ft is equal to, so this t cancel out. So fs is equal to minus 2e upon ts square plus 2e by ts square e to power minus ts, using the time shifting property of Laplace transform. Then this plus 2e ut minus t, so this is 1, so plus this is 1 by s into e, so it is e by s, and minus e by s e to power minus ts. Okay, so this is the way to carry out the waveform synthesis using the gate function. This function can be written by using the graphical composition. What you have to do, take one unit step, then add ramp here, deduct ramp, then we can write this one. So this is the Laplace transform of this. So this is here. This is the last step. Okay. We can solve this example using the graphical composition. So this is your function. This is your function. This is minus e. This is your e, and this is ft. Okay. This is the time t, and this is t by 2. So how can write? I'm just writing a straight way. So it is equal to EUT. Okay. Then minus 2e upon t, 2 upon t, RT, 2e. This is the slope of the line. Okay. Minus 2e upon t RT. Okay. Now the function terminate at capital T. So what we have to do? We have to just deduct the slope. So how much? So same slope 2e by t. Same slope RT minus t. So and also deduct minus u t minus t. So this is the graphical composition. So we can write the Laplace transform of this. So taking the Laplace transform, so fs is equal to e by s minus 2e upon ts square minus 2e upon ts square e to power minus ts, this ramp and this unit, so plus e by s e to power minus ts. So this is using the graphical approach. So what is the summary? Summary is we study the gate function to carry out the waveform synthesis. So there are two methods of carrying out the waveform synthesis. One is the using the singularity functions, that is the unit step and ramp, and the second one is the gate function. So we can use both the methods to carry out the waveform synthesis. So thank you very much. Jai Hind.